for those of you who are new, Big Faith Questions meets here once a month, and we deal with the big questions in life. Questions like, does God exist? Is there meaning and purpose to life? How could a loving God allow so many political ads? You know, that's sort of the questions we really struggle with. And then, so the format here for this morning is I'll finish these announcements, and then I'll introduce our guest, Richard. We're going to do a debate. It'll be a friendly debate. So before, I like to call it a conversation. But this time we did pick a little bit more of a formal sort of format. So I guess, it is a debate. But we'll go back and forth a few times, and then we'll open it up for Q&A. And then that's Richard's chance and my chance to make some stuff up. And then we should, now I did want to mention, we've got a little bit of a late start, and in addition to that, we did decide to take a little more time than we usually do, a few extra minutes, so that we can have enough time to express each of our perspectives. So we're scheduled to finish the sort of formal part of the debate about the time we would normally fully wrap up. So I try to wrap up by about 11:30 typically. We might go, because we're getting a late start, we might go a little bit past that. Then that's when the Q&A starts. So we'd love it if you're able to stick around for the Q&A. If you need to get going, no worries. In fact, even in the middle of it, if you need to get going, we're not offended. I'm a little offended, but only a little bit. And I'm really only offended if you take all the donuts as you walk out. That would be kind of offensive. So we'll have 15 minutes of Q&A afterwards. So we might go about 15, given when we're starting, maybe 20 or so minutes past our normal end time. So we should wrap up sometime before the next Fast and Furious movie comes out. So now, as always, we have the sign-in sheets at each of the table. There's that half sheet of paper. If I could have everyone at least put down your name, that way we know how many people are capable of following basic instructions. No, that helps us know how many people came. And then where it says email address, please write down your email address if you'd like to receive our once-a-month newsletter. It's just a short email I send out once a month. It announces when and where we're going to meet, what topic is coming up, other events that are happening in the Valley that deal with the big questions. So if you'd like to receive that, if you're already receiving it, you don't need to put your email address down again. But if you'd like to receive that, please write your email address down legibly. You have a much better chance of actually getting the newsletter if I can read your email address. So that's kind of how that works. Now, I should mention the restrooms are at the Burger King on the corner. No, they're actually through this door and just right down the hallway. So we've got the restrooms there. Now, I get to introduce our guest, Richard Suttles. Richard works in the field of counterterrorism, and so the rest of his bio just says classified. I can't, no, just kidding. No, he served in the Marines, which we very much appreciate. He runs the Fallen Ape-theist, well, there's an Instagram page, a Twitter page, and a YouTube page, yep. Among others. Yes. So I suggest checking him out on YouTube. It's at the Fallen Ape-theist. And then on Twitter, it's at the Ape_theist. And then on Instagram, the Fallen Ape_theist. If you want, at the end or anything, if you want me to repeat those, I can read those again. But one thing I just really appreciate, we disagree obviously on quite a few fundamental issues, but Richard is always friendly, he's always respectful, and he cares about the truth, which I really appreciate. So I really appreciate Richard. So please welcome Richard. All right, so in order to clearly see the slides, let me test this out and see what you guys think. Do you want me to keep it like that or keep all the lights on? All the lights? Okay, what do you guys think about all the lights? Is that good? Okay, good either way?
I'm not sure how the film's going.
Oh yeah, video, what, the lights on? Okay, good, then we'll do that. That solves that problem.
The other one, was the other one okay for the slideshow, or no? Okay. So like I think the first way you had it is fine. It's just the other one.
Which would you prefer? All lights on or half the lights off? This is fine. Okay, good. that works. All right, so I'll kick it off since I'm kind of making the claim here. So I'm going to be making an argument. Is it all right that I'm sitting down? I can stand if you want. I'll stand because, anyway, it makes it easier for me. So I'll be making the argument that we can know that life is the result of an intelligent designer because of what we discover in DNA. Now, DNA is something that we find in every organism on Earth. It's in every person here, in nearly every cell of our body, and it's in every organism on Earth because it stores the building instructions for building that body. So humans have DNA that stores the building instructions for building a human body. Cats have DNA that stores the building instructions for building a cat body. And bacteria have DNA that stores the instructions for building a bacterial cell. Now, the structure of DNA is really interesting. It's this double helical structure. And so it's like if you took a ladder and twisted it, you'd get that shape, that double helix. Now, just like a ladder, the verticals, the posts of the ladder, are purely structural. They're just there to hold up the rungs. So in the case of DNA, those verticals that you see twisting like that, that's the sugar backbone, is what that's called. And then the rungs, so those are there to hold up the rungs. The rungs in DNA are the nucleic acids. So that's the horizontals you see there. And there are 4 nucleic acids, A, C, T, and G. And those 4 nucleic acids act as letters in a code. Just like how in English we have 26 letters in our alphabet, DNA has 4 letters in its alphabet. And so depending on the arrangement, the sequence of those letters and the repeating of those letters, it spells out different instructions. So humans have a long sequence of those letters that spell out the instructions for building a human body, whereas cats have a long sequence of those letters to spell out the instructions for building a cat body. Okay. Now, origin of life researchers typically, most origin of life researchers try to explain the origin of life naturalistically, using purely natural processes. So they're looking at random chemistry, or what they call stochastic chemistry, to form that first form of life. And so because of that, most origin of life researchers speculate that life began in a much more simple form than what we find on Earth today. Because even the most simple single cell on Earth today is far more complicated, far too complex to form through random chemistry. So they speculate that life originated as something much more simple, not a cell, but instead a proto-cell, something that's doesn't even qualify as a cell. Now, the simplest that origin of life researchers have been able to theoretically boil down, the most theoretically simple replicating system, most theoretically simple proto-cell, still has 3 major components. You have a information storage and replication system. So that would be either DNA, or some say, well, maybe RNA functioned that way, or maybe instead it was something theoretical called PNA. Okay, cool. Something called PNA. Either way, all of those are all 4-letter codes. So it's a 4-letter code specifying the instructions, and then you have to have a system that can then replicate that. So a system that can translate that information into the motions that build a cell, another copy of the protocell. You also need a metabolism. That's where you see that little lightning bolt. You need some form of primitive metabolism, something that can gain energy from the environment to fuel the reactions for building another copy. And also, that metabolism would also need to be able to gather raw materials from the environment in order to have the raw materials to build another copy of the cell. And then the last component, at minimum, that you need is a membrane, some sort of barrier around that to keep the 2 other components together, keep them from diffusing into the environment, and to keep them from reacting with chemicals around it, because other chemicals would react with these delicate systems and tear them apart. So you need some sort of membrane, and that membrane is going to need to be semi-permeable. It's going to need to be able to allow the raw materials in, but keep toxins out, other chemicals out, and it's going to need to be able to let waste out, but not allow the raw materials to leak out before you have a chance to build another copy. Now, there's been all sorts of debate about how you can actually form all 3 of these components using stochastic chemistry, random chemistry. And many of you may have even watched the debate that happened about 1.5 years ago between Dr. James Tour, who's a Christian, he's an intelligent design advocate, and Dave Farina, who believes that life formed through random chemistry. And man, those of you who saw it, you saw they got very vocal. It was a very lively debate, let's put it that way. They were interrupting each other and talking over each other. Richard and I strive very hard not to
that.
not to achieve that. So so yeah, that was a heck of a thing. But there's been all sorts of debate about whether there's even a plausible theory about how you can actually form these components through random chemistry. I'm going to sidestep that entire debate. Here this morning, I'm going to sidestep that entire debate, because even if we had a plausible theory for how the chemicals could come together naturally and form all three of these components, that does nothing to explain where the information encoded in the DNA, RNA, or PNA, where that came from. And let me explain why I say that. When we look at the DNA molecule, obviously it has a lot of information in it. So what component of DNA is actually the information? Is it the sugar backbone, the verticals of the ladder? Is that the information? Well, no, like I said before, that's purely structural. That's just there to hold up the rungs of the ladder. Okay, what about the rungs, the nucleic acids? Is that the information? Well, many people are tempted to say, yes, that's the information, but I actually think, no, that's not the information itself. And let me explain why I say that. I'll use an illustration. I have here a piece of paper, just lined paper with pen and ink on it, that I wrote up just my notes in preparing for the presentation. So it has all the information for the most of what I'm going to say here in this opening presentation. Now, so it has a lot of information on it. Now, is the paper the information? No, the paper's not the information, because even before I wrote on it, it was the same piece of paper, but it had none of the information about what I intend to say. What about the ink? Is the ink the information? Well, we might be tempted to say yes, but that same ink was in my pen before I wrote it, and none of the information about what I intend to say was actually in that ink before I wrote on the paper. Is it the ink plus the paper? Is that the information? Well, no, not even that is the information, because I could take the same ink and the same paper and I could scribble all over it. That's ink plus paper, yet that's still not the information. Instead, but now notice that we're all out of ingredients. We have no more ingredients left. All the chemistry has been accounted for. We have all the paper, we have all the ink. There's no more chemistry to explain here. Instead, information is non-physical. Information's non-physical. It's not the chemistry at all. Now, you might think, well, no, but the arrangement of the ink on the paper is a physical thing. But I think even that is not the information itself. And let me explain why I say that. I'll do another illustration here, why I say information is non-physical. Let's suppose you had a great chocolate chip cookie recipe, and you write down that chocolate chip cookie recipe with pen on lined paper like this. And then you decide, well, I want to share this with other people. Now, this piece of paper now contains all the information to make the chocolate chip cookies. And so you decide, I'm going to put this up on allrecipes.com. You know, the website where you have a bunch of ads around your recipe and you have to read someone's whole life story before you get to the recipe? Yeah, so you put it up on there. So you type it out and you send it over a network cable to allrecipes.com. So now all the information to make the chocolate chip cookie recipe is being stored as electrical signals on a network cable. Now it makes it to allrecipes.com. They decide to approve it. Now it's on their server. Now all the information to make the recipe is being stored as electrons on a solid state drive. If that's a little confusing, don't worry. I'll get to some more standard, some more typically understood technology next. So let's say someone then pulls it up on their tablet and they're like, I want to make this recipe. But I don't want to have to deal with all those ads and read James's entire life story just to look at the recipe. So they decide to take a camera, not their phone, but like a film camera. You guys do realize cameras used to have film in them, right? Yeah, that was a real thing. So they take a picture of the screen and they actually get it developed. So now on that picture, they have all the information to make the chocolate chip cookies. Now it's being stored as light exposure levels on photosensitive paper. Then they decide to read that recipe off to someone on the other end of a walkie-talkie. They read it off over a walkie-talkie. I don't know why they're doing that, but they decide to do that. So now all the information to make the chocolate chip cookies is actually being stored as radio waves. And then the person on the other end of the walkie-talkie is really crazy. They decide to share the information, share the recipe, using smoke signals. To someone out in the middle of nowhere who wants to make chocolate chip cookies, I don't know. But anyway, so now the information to make the chocolate chip cookies is being stored as puffs of smoke. Now, here's my point. Notice that the physical medium has been changing constantly. The chemistry has been changing completely, yet the information is exactly the same. It's the exact same information, even though the chemistry is completely different, because information is non-physical. Now, what this means is you could explain the molecular makeup of DNA. Actually, let me go back to the paper. I could explain the molecular makeup of the paper down to the bonds, the atoms and the bonds between those atoms. It does nothing to explain where the information came from. I could explain the ink on the page down to its chemical makeup. I could even explain how the ink binds to the paper. None of that explains the origin of the information. In fact, I could even come up with a natural theory, a theory for how random chemistry formed this piece of paper and formed the ink and caused the ink to bind to the paper. None of that does anything to explain the origin of the information itself that we find stored on the piece of paper. That's because information is non-physical. It can be represented on a physical medium. It can be represented with physical objects, but that's not the information itself. Well, it's the same with DNA. We could come up with a natural explanation for how chemicals came together to form DNA that does nothing to explain where the information that's being represented on DNA, where that came from. And this is what Dr. Paul Davies was getting at. Paul Davies is a theoretical physicist who teaches here at ASU, and he said, quote, "What we're trying to do in explaining the origin of life is to link the world of particles and energy and forces with the world of information and codes and instructions. No amount of atoms will give you instructions alone just on their own. So when we're talking about the origin of life, we have two things to explain. We need to explain the substrate, the hardware of life, but we also need to explain the software. How did the software come to exist? In other words, where did the code come, how did that come to exist? So we need to know, where did the information come from? Well, I propose we already know where the information comes from. We already know where information comes from, because in our consistent experience, information always comes from a mind. Information always comes from a mind. Let me give you an illustration to help make this clear. If you were to take a ferry across to Victoria Island in British Columbia, as you approach the harbor, you'd see an arrangement of flowers on the hillside that looks like this. It says, "Welcome to Victoria." Now, as you're standing on the deck of the ferry and you see that, you're not going to say to yourself, "Wow, isn't it amazing that the flowers just happen to grow that way?" Look, no, you're going to say like, "Whoa, what clever person did that?" And if someone's standing on the deck of the ferry next to you and they say, "You know, I have a theory for how that formed. I think some wind blew the seeds across the hillside and they happened to fall like that and happened to start growing like that." You're not going to say, "Well, that's a really interesting alternative hypothesis." No, you're going to say, "What? Man, no way." Like, clearly, this was intelligently designed because it conveys information. Now, it's not just any information that's the hallmark of intelligent design. The word information has been defined in a lot of different ways. So we have to be very careful about what we mean by information. The type of information that I would say is always the hallmark of design is complex specified information. Complex specified information. So let me do another illustration to explain that. How many here have ever eaten alphabet cereal? Has anyone ever? Okay, yeah, we've got a few. I actually can't raise my hand. I never ate alphabet cereal, and my wife and I were saying we should buy a box of alphabet cereal just so I can, because I use this illustration. It turns out you can't buy it anymore. It's no longer made. It's sad. So I wasn't able to buy it. So, let's suppose you had one of the last remaining boxes of alphabet cereal. You take it to your dining room, you set it on your dining room table, you open it up, new box, brand new, and you realize, I forgot the milk. So you turn, you accidentally bump the box, and it knocks over and dumps all the contents out onto your dining room table. Now, those of you who are a little OCD are already getting a little nervous. Don't worry, we'll clean it up. But you accidentally bump it. You don't realize you bumped it. So you just bump it, and you keep going. You go back to the kitchen. And so you go into the kitchen, you grab the milk. It's a couple rooms away. You come back, and you look at the table, and this is what you see. Now, I had to use plastic letters because we weren't able to buy a box of alphabet cereal. But this is what you see. Now notice right along here. Please clean this up. And you look at that, and are you going to say, "Wow, isn't it interesting that it just happened to fall that way?" No, you're going to say, "Okay, who's messing with me?" Like, clearly someone is messing with me. Now, let's change the illustration a little bit. Let's say instead you bump the box, you don't realize you bumped it, all the contents spill out onto the table, and you come back and it says this. Wow, W-O-W. Now, are you going to start looking around to see if someone's messing with you? Probably not. You're going to say, "Well, that's kind of interesting, but it's just W-O-W." What's the difference? Well, it seems like with the first one, this pile is more complex and this pile is more simple, but that's not actually true. There's some truth there, and I'll explain. But actually, as the pile as a whole, either one, they're both equally complex. They're both made up of the same number of parts. If you were to try to geometrically map the location and rotation of all the letters, it would take just as much data to be able to map either one of these because they're equally complex. Instead, the difference is that the message, the part specifying a message in this case, is more complex. This is complex specified information, whereas this one, the pile is complex, but the part specifying a message is actually really simple. It's just WOW. So I think it's when we find complex specified information, that's the hallmark of design. Well, what do we see with DNA? Well, we certainly see complex specified information, whether it's human DNA, but even the most simple, theoretical, most simple protocell would still require complex specified information. Would it be specified? Yeah, it specifies the instructions for building another protocell, all three of those components. Would it be complex? Absolutely. It would absolutely be complex. Different origin of life researchers have speculated about how complex even that most simple protocell, the simplest it could possibly be and still be able to replicate. And there are all sorts of numbers thrown around, but the smallest number is by Eugene Koonin, and he estimates that at minimum, you're going to need 318,000 base pairs, 318,000 nucleotides, letters of the code. Now, if you were to take those 318,000 letters and print them on 8.5 by 11 standard printer paper in just 12-point font, you would get 106 pages. This is 106 pages. This is a specification book that I wrote for a remodel project I did in the Fowler School District. It actually was thicker than this. I had to take some pages out to get it down to 106 pages. But this has all the information that we hand over to the contractor that specifies all the materials, how to use the materials in the project. So believing that the first, even most theoretically simple protocell formed through random chemistry is like believing that this entire specification book with the paper and the ink and in the arrangement that it specifies all the instructions happened to form through random chemistry. And I just think that an intelligent designer is a much better explanation for something like that. So that's my presentation.
Awesome.
So,
Clap?
yeah,
I want to clap.
we'll clap for both. Yeah.
And actually, I don't have slides. I'm just actually the slide that you had that go that.
Oh, do you want me to this one?
Yeah, you can keep that up.
Okay, cool.
And then there's the quote from Paul Davies. I want to put that up. So
Okay, cool.
Later.
Yeah,
We'll do that later.
Just let me know when.
Okay. And then how much time is it again? I forgot.
20.
You were almost 3 minutes under.
Oh, okay.
Okay.
Cool.
So 20 minutes.
Okay.
All 19 here at 20.
Awesome. He's our timekeeper. Because man, I have a tendency to ramble, so he'll keep me honest. Okay, so thank you all for being here. This is my third debate against James. I've actually been here several times. I came here a few years ago when Lee Strobel came to visit. That turned into a Bible study. Thank you, Mike. And became part of a Bible study group and met James, and that led to one debate here, one at ASU, and now this one here. So I've always felt welcome here, and I like this church a lot. So although I'm an atheist, I don't preach atheism. I think maybe I was in my 20s when I left atheism, I'm sorry, when I left Christianity. So I was born and raised in a church almost identical to this one. And maybe walked away from 17 to my early 20s. So now I'm 54. 30 years, I think only one person has ever said, because of what you said, I'm now an atheist. I think only one person. And even that was online, so I don't even know what I said. I don't preach that. I'm like, we've got to be able to get along better. Like he was saying before, the debate with James Tour and Professor Dave, he goes by Professor Dave, he's not a professor. That was so vitriolic and so angry. And then if you watch people who saw it, they say, oh, my guy won and he trounced your guy. The actual origin of life, the topic of origin of life didn't move forward at all. If anything, people just got disgusted with origin of life. So the actual topic itself was lost because they both wanted to be correct. So they need to be correct. As he said before, I work in counterterrorism. I've done that for 30 years. And at some point, learning about counterterrorism and reading people dehumanizing each other. And man, if there's one thing terrorists do is they write stuff down and they record themselves, and they talk about why you need to destroy other people. And so we go through all that stuff. And me doing that sometimes 16 hours a day for 30 years, I was like, there's got to be the opposite of that. And so my ministry, I use the word ministry because I was raised Southern Baptist. My ministry is just to not do that and to find a way to be more productive and friendly. So that's what I'm about for those of you who haven't seen me. So there's going to be no screaming. I'm actually going to blow your mind because science is a lot more complicated than what he just said. It's sometimes a Christian will say DNA is very complicated, and then the atheist is like, no, 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 and he'll pull out a particle chart from Sean Carroll, and he's like, that's all easy, please read a science book. That's wrong. What he said is correct. It's extremely complex. The only thing that's missing is that it's a lot more complex than even that. And so I'm going to get into why that is. A lot of this is based on scientific research that's been happening for the last 10 years. A lot of the scientists are naturalists. They're atheists. They don't believe in God. And they're like, but I can't explain this. And I don't know why it's happening, but this is happening. And we're going to get into that. I don't know how many of you saw this movie, and I can't even remember the name of it, but Jeff Bridges was in it. And he played a guy who owned a car company. And this was like the world's first national car company. And there was already cars, but it wasn't a national car company. And so Jeff Bridges wants to do that. He goes and he buys a car, and he brings it into his garage. This was like 1910 or whatever, maybe like 1910. He brings the car into his garage, and he completely disassembles the car until it's just all down to little tiny pieces. But now he knows how to build a car. He knows all the pieces because he's completely reduced that car down to his components, and he was there to disassemble it. And so he takes that knowledge and his knowledge about how to build businesses and creates a better way to manufacture cars. And a lot of us are driving those cars today. I forget which car company it is, but that concept about disassembling something and understanding it after you've disassembled it and then understanding it, that's a real thing. That happens. But the universe gets weird. If you were to take one of the tires of the car and you were to try to disassemble that tire, just the rubber of the tire, and you get all the way down to just the molecules, there's somehow, let's just say there's another big giant warehouse, and there's a way to separate the atoms from each other so they don't bond. And then you get into each of the atoms and you separate the atoms into all the little quantum wave functions, because an atom is basically just several different quantum wave functions that are interacting together. And if you could just separate all those quantum wave functions in this big giant warehouse, and somebody were to walk in and see all these big quantum wave functions and say, oh yeah, that's a tire, I can tell. It's not going to happen. You're not even really going to see a quantum wave function, but even if you could, you would say there's no way to know that that's a tire. But it is. Somehow all those quantum wave functions got together along with the laws of the laws of physics, the four physical forces of the universe that we even know of right now. And we didn't even get into that. Somehow all of that comes together to get to be a tire. And you can't see that from the quantum wave function. So in that particular situation, when you get to the tire on that car, you can't really reduce it down to the parts and understand the tire. But the car you can. So I think sometimes when we do the origin of life, people say, okay, we see life, let's reduce it down to the parts, then we'll understand it. And it looks like that might not be possible. So, and I think atheists get mad because they're saying, if I can reduce it down like the car, then we'll understand it and we don't have to talk about God anymore. A, that's not true. That's not what would happen if we did that. But B, we might not be able to do that. And I'll get back to what would happen if we actually do come up with a natural explanation to life, because that's quite surprising. Just going from the big questions, it doesn't matter whether you've even heard about God or if you've heard about atheism. If religion never even came up in your life and you're just trying to get through the world and you're just studying science books and you know that there's a universe and there's a space-time fabric and this space-time fabric is expanding and there's little quantum wave functions that somehow become atoms and then stuff, and all these things just keep happening, it would be fair to say how. And A, why is there this stuff? Why did this stuff happen? So this is why these questions are important, because you don't even have to talk about God. You don't have to talk about whether religion has any problems. Sure, you still want to know, how does this stuff happen? So this is where science is great, because they're trying to figure out why is there a universe? Why is there anything at all? And then once it gets to the stuff, how does the stuff turn into processes? And then how does life happen? And then once you have life, how do you get complex life like us? And then why do we start behaving in tribes? And why do we become like a social network? And we can make satellites and air conditioning and things like that. You know, how do all these amazing things happen? Atheists made a big mistake around the 1970s. Anybody here really kind of study the debate like between atheists and Christians? I know you have. The big mistake that the atheists made was that they said, okay, there's nothing in life that has agency at the small level. So like cells don't have agency. So what the cells are doing is they're following instructions from the DNA. And so whenever you talk about what cells are doing, you have to say that they're just following a program from DNA. That's not what's happening. There is a lot of that, but that's not the only thing that's happening, and I'll get into why that is. But they were so against something called teleology. Anybody know what that is, teleology? Basically, cells have goals. They have goals, and they work together, and they're like, okay, so if they're like cells on an amphibian, and the amphibian's leg was dissected, the cells in that area were like, okay, we've lost a leg, we're going to put a leg here. And so the cells literally work together to make that leg. And then when they get to the leg, they're like, okay, we're done. And for a long time, people were like, well, the DNA says to do it, and then the cells do it, and then they report back to the DNA. But that's not what happens. And in the last 10 years or so, they've figured out that they can take a specimen, and there's a specimen called a planary worm, I think is what you call it, but it's like a flatworm. And they can dissect the flatworm. And when they do, if a flatworm, this is fine. The flatworms just, each side regenerates. So the tail regenerates the head regenerates the tail. But what they did was they noticed that when they dissected the flatworm, all the cells at the dissection started doing a bioelectric language. So there's a book called The Secret Language of Cells. The cells started saying, hey, we don't have a tail, we're going to build a tail. And then this one was like, hey, we don't have a head, we need a head. The scientists took the bioelectric signal from a planary, which is easier for them to do now because it's just a worm. Like they can't do it for one of our arms. And by the way, even if they could do that, it would take years and years and years for a new arm to grow. That's why humans probably aren't going to regenerate anytime soon because the time it takes to do that. But for this worm, they took the signal for grow another head and they put it on the other planary worm. So you ended up having a two-headed planary because the scientists had changed the signal. And so the cell said, okay, we're going to do a head, change that. And so now you have a two-headed planary. Here's the funny thing. They dissect that two-headed planary worm. After it became two-headed and they dissected it, each one of those grew a new head. So now you had two. So now you have a completely different species. And guess what? The DNA hasn't changed a bit. They measured the DNA. And like he says now, we can unravel it and get to all these amazing things. And the DNA hasn't changed. Another example, that amphibian that I was talking about, they took an amphibian that doesn't regenerate, regenerate limbs. So if you dissected a limb, this particular amphibian just doesn't regenerate. It'll just say, I'm sorry, it's too costly, we're not going to do it. But there's an earlier generation of that species, an earlier species earlier in time that's still alive. And they do regenerate. So they dissected the limb, and they took the bioelectric signal for put a leg here, and they put it on the cells of this other animal that doesn't regenerate. And that animal came close to a leg. It wasn't an exact leg, but it used to do nothing. The cells got the new instructions and did their best based on these new instructions to put something like a leg, which was not from the DNA, it was from the scientists. The cells were problem solving. And that's a new thing. This is something that I think, so I've got two high school girls, and I'm telling them everything you're learning in biology, this is going to be maybe in your lifetime. I don't know how long it's going to take for mainstream science to report on this. Because, by the way, neither Christian scientists nor atheist scientists like this. They're not happy about this because the cells are doing their own thing. They're not listening to the DNA. They're saying, let's put a leg here. Once you get the bioelectric language right, then the cells are doing their, so the cells have a goal. The cells have a goal. If you try to obstruct them, they work around that the best they can to reach their goal. They reach their goal and they stop. No idea why that happens. And so like one of the scientists, and I think you have a handout from him, Michael Levin, if you go to his page and see his research, he'll say, I don't know. And he's an atheist. He's like, I don't know. And then so when atheists and Christians are like pressuring him and saying, well, we got to work this out, he's like, well, you guys work this out because here's the thing. Cancer does that. Cancer, what happens with cancer is that the cells say, we're going to be cancer. And it's inside of a person, and the person's cells are like, no, we're going to be a person. And the cancer cells are like, nope, we're going to be a cancer. And so they create their own tumor, then they create their own networks, and so they start thinking, just like a living organism inside of you, and they do their own thing. And this scientist, his name is Michael Evan, he's like, I'm going to learn how to tell them to stop doing that. So that's where his focus is. He's not thinking about how does this happen, why are cells thinking. He's like, I want to learn the signal for stop that, because there is a signal. And sometimes people or sometimes animals will have cancer, and the other cells will say, kill yourself, and the cell kills itself. So, but what happens with cancer that's successful, at least from the aspect of cancer, is that it just doesn't do that. It remains stubborn, and they become cancer cells with a plan and a goal, and that's where they do the tumor and the network. So the reason why a lot of theist scientists don't like this is because there's no plan beyond that. The cancer cells have a plan to take over the organism. What those cancer cells don't know is that when they win, the host dies and then they die, and all that was for nothing. Nobody wins. Obviously, if it's a loved one, you can say it's evil. But if it happens like in a whale in the middle of the ocean, and they have no family, then it's hard to say evil. It's just a thing that happens. It's just as awe-inspiring and mind-boggling, and we don't know the answer why that's happening, but it happens. And so this is the next, for me, this is the next big thing in science, is how are cells thinking? I couldn't get a hold of Stephen Meyer about this, but I could talk to William Dembski about this. And I don't know if you guys know the name William Dembski. Do you know him? I went to go see him at a lecture last year, and the host of the, he might be right here at Christi, yeah. Okay. He let us go, we all went to dinner. And so I brought this up. And William Dembski, and he actually brought this up in his lecture later. William Dembski thinks that there is a real-time signal that comes down to the cells, and like to embryos too. There's a real-time signal that comes down and says, hey, this is what you're going to do next. And so then the cells take that signal, so William Dembski is thinking that's why they're thinking, is because the signal comes from there. Now, I've had people say, well, that sounds ridiculous. How could he think that? But when I tell you all the stuff that the cells do, then they're like, well, where does it come from? We don't know. So then the real-time signal suddenly sounds more reasonable. So it's a mystery. Why is this happening? Why are cells doing that? I don't know. It's inspiring when it happened to, for my kids being born, it's inspiring. But if it's cancer and someone dies from it, then I'm not inspired anymore. But it's the same, I'll use the word miracle, it's the same amazing, mind-boggling thing that you don't understand. But it's just, in one case, it's meaningless and tragic, and the other one is inspiring and amazing. So why does this happen? We don't know, but it's even more amazing than that. So atheists messed this up because they were talking about this in the 50s, and some of the atheist scientists put their fist down and said, no, there's no teleonomy, there's no teleology, similar things. There's no agency. They're following instructions from the gene. That was in the 1970s where they put their foot down, and that was called neo-Darwinism. It's all genes, it's all mutations. It's not. I'm an atheist. It's not that. And Richard Dawkins is still fighting this. There's another guy of equal stature to Richard Dawkins named Dennis Noble. And Dennis Noble has been studying biology right alongside Richard Dawkins. And Dennis Noble is like, yeah, it's more than that. And Richard Dawkins is like, no, it's not. And they've been arguing about this for decades, and they'll probably go to their graves arguing this. But you can look up Dennis Noble and read some of the stuff. I'm on Dennis Noble's side. I think that there's this other stuff going on that we don't understand that has agency. And I think this neo-Darwinism was a mistake. But one thing neo-Darwinism caused was it caused a lot of Christian organizations like Discovery Institute, which is where Stephen Meyer works, to have ministries where they have scholars talking about how complex DNA is and how amazing that is and how that points to a creator. That's too small. It's not just the DNA, it's the cells. And they probably never would have done that if the new atheists back in the 70s hadn't have said, you're just following a code, the DNA produces the code, and that's all it is. And then it's mutations, and there's the whole game. And that's just not true. And of course the Discovery Institute was going to just fly with that, because it's not true that everything is just genes and mutation and natural selection. It's a bunch of other stuff too, that the Discovery Institute. So whenever the Discovery Institute puts something out, a lot of my atheist guys are like, oh, those brainwashed guys. And I'm like, well, they don't even mention God. They're just talking about experiments. They do mention God, but in these research papers, they don't. They're just talking about things that are happening that don't align with gene-centric and natural selection. So this has just been a problem. And I've always been saying that don't do that. Work together. Work together and find out what it is, and then go with that. Real quick, how am I doing on time?
4:45.
So 4 minutes left? All right. I do want to get into information, and I want to get into what would happen if we really do prove that all of our questions in life, from the universe to stuff to information to life to consciousness to morality to beauty to math, what would happen if we actually found a natural explanation for all of that, so there was no more questions? What would actually happen if that does that? Before I do that, I just want to say something for information. If a planet is moving through the space-time fabric, you guys know that like space and time is like the same fabric, even though it's hard to visualize. When a planet moves through the space-time fabric, it warps it, but it also leaves a warp. So you could, if you know what to look for, you could go to a part of the space and say, oh yeah, a planet was here. Look, it's like aliens know what to look for. They're like, yeah, I can see it. It was probably 13 million years ago, 13 million, per Earth time. It's probably this size mass. So you come in. I think that's vocab Malone.
Oh.
So for me, that's the potential for information. The planet passing through space-time leaves the potential for information. Now, there's no aliens coming to read, let's just say there's no aliens coming to read the space-time fabric. They don't see the warp. So maybe there's no one to pass that information. Maybe it's not information yet because you haven't had somebody come and read that the planet came through the space-time fabric. So the potential of information is there. Once the planet moves through the fabric, you have the potential for information. So I just want to say that doesn't require a designer. That doesn't require a mind. You have the fabric, you have the planet, it moves through, leaves a warp, there's the potential. All you need is somebody who understands it. Now you can say the fact that somebody understands it, there's your mind, and maybe somebody had to set up the structure so that there's this fabric and a planet. Maybe you can say that. So I don't think that destroys the idea of a mind. But just to point that out, that actually the potential for information can happen naturally. And then the final thing that I want to say is, even if science answers this question, all the questions are answered. Let's just say in 10 years from now, so it's 2024. So 2034, the answers in Genesis, Discovery Institute, all of the science, Richard Dawkins Institute, I don't know if there's such a thing, the super atheists, all of them get together and say, nature answers everything. We can answer everything. Space-time, all of it. All the quantum, it's all answered now. There's no more questions anymore. The day they do that, you know what theists can say? How amazing that is. So that's so amazing that we could be in this reality where everything unfolds in just such a way so that 14 billion years ago, there was this stuff, and we could explain why, and we could explain how all that leads to us, and I can answer all of those questions. Theist scientists will be publishing books. We probably won't have books then. We'll probably have mind melds or something. But all of those answers will be like fine-tuning. Have you guys ever heard the fine-tuning argument? The fine-tuning argument will be the greatest ever. Every single person. So any kid has a question, we'll answer it. And then the kid can say, why are things like that? And then the theist can be like, exactly. Why are we living in a reality where all these things can unfold just so, and there's no more questions? I think right now, how am I with time?
1 minute.
Okay. Okay. I think right now what you have is scientists at the Discovery Institute saying nature will never answer this, and so we can infer God. And then you have atheists saying, no, it's all answered. Stop talking about God. They're both wrong. They're both wrong. There probably will be a natural explanation. It'll be probably robust and amazing, and we can't fathom it right now. But when we do it, you can still say praise Jesus. It won't change Christianity at all. It'll just say things are just a lot more complicated than we thought, and we can explain it. So I would always say if you hear somebody arguing, an atheist saying, it's all figured out, you can say, no, it's not. And if a Christian says, they'll never answer it, say maybe they will, but it won't change anything. So that's been my message, is that go ahead and find the natural answer, but don't worry if you find it. It would actually be good for you guys. That's it.
All right, cool. All right, so I believe the next segment, I'm asking Richard questions.
It says Richard asked.
Oh, you asked me questions.
Ooh.
Okay, cool.
Actually, I was waiting for you to go first. Is it okay if we switch? Because I'm not even thinking about questioning him yet.
Okay, cool.
You go first.
Okay, yeah. So a few questions here. You mentioned that atheists had made a mistake saying that nothing in life, especially the small aspects of life, like a
Right.
cell,
Yeah.
has agency, but that's not right. Cells have goals.
Yeah.
And when you use the term goals, I'm concerned that maybe the word goals can mean a lot of different things. So
Right.
what specifically do you mean by goals? And, well, I'll just ask that first.
Okay. So this is confusing because this guy, Michael Levin, he's on Twitter, and I've been pestering him because I was expecting this. And I'm like, how do we describe this? And he's like, okay, I don't know if goals is right, but here's the thing. When you cut off the leg of that amphibian, the cells say, put a leg here. And they just keep saying that. You try to stop them, and they just keep doing it. Not only that, you can go to the back of the amphibian and tell those cells, put an eye here. And the cells will put an eye there. They know what an eye is, and they put an eye there. Not only that, the eye can't get to the brain, so it develops neural pathways to the spinal cord, and then that amphibian can see out of the eye in its back. So, and this isn't any genetic change. This is all the cells. And so, for goal, for some reason, the cells are saying, we're going to put this specific thing here. They have a bioelectric signal for it. And for these small things, the scientists know somewhat. Like, they don't get the leg exactly right, but the fact that the amphibian can grow something, and the fact that it does grow an eye, and the eye works, and the cells know this has to see things, and it goes to the spinal cord. And this is all on the guy's web. You can go to his website and watch all this unfold.
And that is on the back side of the handout there.
Yeah.
So I wanted to ask, does that mean then, it sounds like you don't mean goal in the sense of free will, like a cell has a free will?
So
It's
here's,
making decisions?
this is a whole thing about free will and morality. Because in my mind, free will and morality are the same thing. Nature produces problem solvers. So if the goal is to keep surviving, it's not just survive, it's to have certain things. So like this problem-solving amphibian is like, I need to have 4 limbs in order to survive. So they are reacting to being dissected, and they are saying we are going to put a leg here, because a leg happens, and they try to stop them, and the cells still find a way. Now, can we hear the cells saying that? There's no neurology. When the cells say, put a leg here, there's no neurology happening. There's some sort of bioelectric thing happening that scientists can't explain. So they are reacting to it. They are coming up with the goal, and then they are implementing it. Now, are they determined to do that by chemicals or physical forces? I don't know.
Okay.
I've always said that the thing about free will and determinism is, when a rat is in a maze and it looks left, there are chemicals in the brain, in the rat's brain, that says, if you go left, this is what's going to happen, some good, some bad. And he looks right, and the neuroscientists can measure the rat's mind here. There's neurochemicals, dopamine, saying, if you go right, this is what's going to happen. And based on the dopamine, the rat chooses, and the rat goes to the left. What happens is they change those experiences, and the next time the rat's like, I'm never going that way again, and he starts going this way. But it is, so in one aspect you can say the dopamine forces him to turn left or turn right. However, I think if determinism was true, there wouldn't be any analysis at all. The rat would be born and he was going to always turn left and he was going to always turn right. There's no, you never feel the analysis. Like when we all go through that. You're driving home from work and there's this brand new casino, but you got to get to work. Maybe I'm projecting me onto you guys. We all feel that. We feel those different ideas popping up in our mind, and I think that's dopamine algorithms going off. And if your algorithms are good, and I think it's on trial and error, then you keep going home, and I do. But I just think that's, chemicals are informing that, but at the same time, if determinism was true, I don't think there would be any analysis.
So to me, it kind of sounds like you're describing something like an AI system, like these Waymo cars driving around, where there is at least a system for analyzing different routes and
Right.
learning, from. But even that still has ultimately there's an explanation. And so to me,
Right.
it sounds like maybe what you're saying is there's something beyond just the mere DNA or the basic systems that we know about currently.
There
There's
absolutely
more to it, maybe in the bioelectric connections between these different parts,
Right.
that still, in a sense, is pre-programmed to put a leg there or pre-programmed to put an eye there.
Right. Yeah. This bioelectric language between cells, and again, mainstream science isn't taking this on yet because people don't know what to do with it. it's still something. So even if we prove that that's all it is, it's still, why is it like that? Why do we live in a world where cells have this bioelectric language? And what languages were they telling to each other before they figured out the leg?
Okay.
So it's a good question.
One other question, you'd mentioned at the cell level, at the molecular level, individual molecules, do
Yep.
we see molecules solving problems?
To a degree. So here's one thing. This was going to be my final answer, but since you or in my final word, but since you brought it up, I want to go ahead and say it now. This guy Michael Levin says all intelligence is collective intelligence. So you can't get to intelligence until you get a bunch of stuff that isn't intelligent working together, and somehow through chemical reactions and this energy, then it becomes intelligence. This is one reason why he doesn't think there's a God, because that would still be an intelligence, in which case it would require a collective of other things that weren't intelligent to get to him. So even the Trinity doesn't work for him. So he doesn't know. So it is an intelligence, but he can't explain why. But he does say in every single case where you get to problem solving, if you backtrack it, there's things that can't problem solve on their own. So at some point, the molecules plus the energy got to those layers. How it happened, I was never going to fight that. By the way, there's a guy named Nick Lane, who's an atheist scientist who's been studying this for decades, and he's written books on it. And he gave a lecture the other day, and he's like, "We're never going to solve this." And he's atheist. He's like, "It's just not going to happen. Stop trying to figure out exactly which molecule led where. It's too complicated. It's never going to happen." So I knew coming in here I wasn't going to try and read all of his books and answer why all that happens. Somehow it does, and I realize it's a statement of faith, and I'm okay with that.
All right, thank you.
And honestly, I don't really have too many questions for you, because I had read that, and I had watched those videos. I was really impressed. There's a video, I forgot the name of the title again.
Long story short,
Yeah,
it's mentioned on the back side of the handout as well.
This long story short on YouTube, if you type in long story short and maybe chemical evolution, might be good, because there's several long story shorts on YouTube. But yeah, it's very similar to what you were saying. I was just going to say I really like that channel, because they're very even-tempered. There's so many channels. I'm guessing most of the people in this room are Christians. If there's one piece of advice I would say, is that when you're talking to us, don't be angry. I understand why, because there's so many jerks over on my side, but so many YouTube channels are just kind of angry, and so I was just going to say I appreciate for you seeing that. I didn't have too many questions except to say, like, if you were to look into the stuff that I'm talking about and the cells and stuff, would it change anything about how you see God?
Yeah, I appreciate that. So I'd have to look into more the objection regarding the Trinity. That doesn't make sense to me, why that would be an objection. But what you were saying, though, about would it change the topic at hand?
Right.
So I think the answer to that is no, it doesn't, because it sounds like there's a lot we still need to learn about the DNA and the interactions with the rest of the cellular structure. So we've been learning more and more that the actual development of an organism goes far beyond just the DNA.
Yes.
And so,
Exactly.
so the actual cytocellular structure, a lot of the chemical interactions between cells, even the environment itself makes a difference. There are feedback systems. There's a lot more than the DNA, but there is at least the DNA. So just like with any other program, you might have a program that runs a certain code in a computer or even in your phone, but there might be a lot more to it than just that. It's far more complex than that. But at minimum, the programming in there, like let's say the operating system, does play an important function. So we need to explain where the coding came from, even if we don't fully understand where all the rest of the complexities of the cell came from.
I really don't have any more questions. If we have time, do you want to just ask me more?
Sure. Yeah, that'd be good. I noticed you'd mentioned there's from what you were describing, I take from it that there's a lot that we're still learning about the cell and interactions. So when you were hearing my case based on information, were you taking that as a sort of God of the gaps argument, like an argument from ignorance, that I'm saying we don't understand how DNA or how the cell works, therefore God is the best explanation?
No, because so there's two. I'm glad you brought this up because this is important. I can, in all my years of talking to Christians, I have met Christians who said, I don't understand it, but I was raised that God did it, so don't talk to me. God did it, and I'm not going to talk anymore. Now, that's something like God of the Gaps. I don't understand it, so I'm just going to go back. But Stephen Meyer, I've read his book, Return of the God Hypothesis. If you guys haven't read that, it's a fairly new book. And it's a really good wrap-up of of a lot of science. Yeah, this book right here. That's not God of the Gaps. He's really looking at every single question that we have. And all a gap is we don't know. We can say, hey, we know this much, and then we get here and we don't know. We get here and we get this much. So he's like, I've looked at this from every single angle, and I cannot find any other answer other than an intelligent being wanted it to be like that. I think that's wrong, but that's different than the guy who's like, hey, God said so, leave me alone. He's looking at it, and he's really doing his best to figure out. He's biased. He's gonna think it's God, but he's got a lot of science there too. So I don't see that as the same thing. Okay. But I do want to say we all have the same gaps. Atheists and religious, we all have the exact same gaps. We don't know the answer until we can demonstrate it. We don't know. So if you're a Christian, you can say, okay, I don't know it, but I have some good reasons to think this. So I think that's what I would say if I was a Christian.
Gotcha. Okay. I was also going to ask, you'd mentioned when a planet moves through the fabric of space-time, it leaves behind sort of a warped space-time.
Right.
And I think you'd mentioned it leaves information, or at least the potential for information. So I think your words were, the potential for information can be explained naturally.
Right. Except for the fact, why is there space and why is there a planet, and why does the planet live? Yeah, that's always going to be there. That's
the foundational, like fine-tuning sort of question you mentioned.
The fact that there's existence itself should always give everyone reason pause. Like my wife's Christian and I'm not, and we raised our kids that everyone's religious. So most people are religious. Our oldest decided not to be, and she did at a very early age, and our 4-year-old is a believer. The 6-year-old was trying to convince the 4-year-old a long time ago. They're in high school now. She was trying to convince the 4-year-old to not believe by telling him crazy stories that the Mormons had said. So she's like, you can't believe in God because the Mormons had said this, this, and this. Because, man, were the Mormons at our house when our girls were little. Man, were they at our house. Like, well, please come join church. Looking at our kids. We would love to have them, married with kids in 10 years. So she was trying to tell her, just don't believe in God because of all these crazy stories. And the 4-year-old, and I'm driving the car, the 4-year-old looks out and she's like, but look at all this stuff. A 4-year-old said that. And I wasn't teaching her. I never taught them to not believe. I said most people are religious and maybe they're right. I don't know. So I gave them kind of an agnostic answer. But she said, look at all this stuff as a 4-year-old. That's always going to be a great, compelling reason to believe, I think.
Okay, gotcha. But when the planet leaves behind this warped fabric of space-time, is that complex specified information or information more in a different sense?
Well, at that point I think it's just potential because you need to have an agent that can come and look at it and say, I know what this is based on trial and error or whatever. I know that this warp wouldn't be here unless a planet came through.
Okay, so we don't see like digitally encoded instructions left behind by the planet.
I don't know if it would be instructions, but it would say something. It would say there was a planet here this time. So
we could derive information from that. Okay, I get you there, but we don't actually see like an encoded language left behind. Okay.
And see, I would say there's a difference between information and instructions.
Okay.
I do think instructions are saying this is how you get to this specific point, whereas information is like, this is just something that happened. You don't necessarily have to do anything with this.
Would you say that instructions are a subset of information? It's a smaller category within information?
Yeah,
okay.
I'll go with that.
Okay. You'd also mentioned that scientists at Discovery Institute are saying that there will never be a natural explanation for, like, let's say, DNA.
Right.
So I've never run into a scientist from Discovery Institute who actually makes that claim. Have you actually heard a scientist from Discovery Institute say we'll never come up with a natural explanation?
That's a good point. So I know Stephen Meyer was on Joe Rogan, and he'll say something like, scientists say that there's a natural explanation. I'd love to see it, something like that. I don't think he's ever looked at the camera and said it's never going to happen. So that might have been me adding hyperbole to what he said.
Fair enough, yeah, because I think at best, and in this case I agree with you, I guess, that we have our knowledge at the time, and we can assess how complete our knowledge is, but there's always the potential we could discover something new. So we should
Right.
stay open-minded.
And I think he does. Actually, Stephen Meyer does a really good job of doing that. So
Okay,
that,
good.
That was my bad.
Good.
You got me on video.
No, no,
was
no
my
worries.
bad.
Yeah,
I
no.
overstepped
I just
that.
wanted to clarify. All right, so I think those are my questions for that segment. I think we have one more segment where Richard can ask me questions. Did you want to
No.
continue with that?
No.
So that's a 6-minute segment for each of us. Would you rather just take the 6 minutes in closing, or?
You know, my closing was really what I said before about how if nature, even if we do find a way, is not going to change anything. So my closing is kind of done. But
Okay.
You can do one if you
Oh,
want.
is that all right?
Yeah.
Okay, that means we'll have extra time for Q&A, but let me just, I'll just address a couple things in closing, and then I'll wrap up with just a summary of the argument.
Okay.
So I appreciate you pointing out the discoveries that we're making. I thought the new trends in evolutionary biology conference in 2019 at the Royal Society, I thought they brought up, Dennis Noble brought up a lot of those things that we're seeing. And Levin and Lane, in your handout there are Darwinian scientists who do bring up these things. I think there's a lot more we have to discover about the interactions within a cell. But I think what we're still seeing is there's some sort of biochemical system in the cell that is saying to put a leg there, to put an eye there. It's pre-programmed to some extent, solving problems.
Yep.
So it's not pre-programmed in the sense of it always does the exact same thing,
Right.
but pre-programmed to solve problems like our computer programs do today. And we do see goals, I think, in that, but not goals in the sense of like giving reasons for so when we talk about goals, we talk about having a free will and making certain decisions based on reasons. Not everyone's decisions are based on reasons, but
Right.
Certainly that's an aspect of it. So I don't think we see goals in that sense, but definitely in a sense, it seems like it's goal directed. Do we see? Oh yeah, I don't think we've seen any evidence that molecules are solving problems.
Right.
That I think, like you said, collectively when they come together in certain arrangements.
Right.
Just like with a computer, you can have a collection of molecules. A computer is a collection of molecules. My cell phone is a collection of molecules, and it does solve problems and reacts to certain. Like if you put a phone on top of certain types of chargers, it'll actually activate a certain mode, like the car mode or whatever, airplane mode or whatever. So it's reacting to the environment, that kind of thing. Cancers seem to have many of these same systems.
Mm-hmm.
I think we're seeing, for the most part, still cancers seem to be the result of mutations with a complex set of problem-solving mechanisms built in. But there are these mutations that seem to mess with those biochemical systems. But there might be a lot more than just genetic mutations. That gets into the problem of natural evil. Since it's off topic, I won't get into that here, but I think there's actually a lot, there are a lot of great books on that. Dr. Michael Behe talks about that. And so let's see here. Oh, and then also, I think you'd mentioned theists don't really like this idea of that there's a lot more than just the genes, and there are these sort of biochemical
Right.
systems that are solving problems.
Some of them don't.
Because it kills the host as well as the cancer.
Right.
But it seems to me that's actually really difficult to explain on a Darwinian perspective, not
Absolutely.
just neo-Darwinian, but the extended evolutionary synthesis.
Right. In any way, it's hard to explain. Absolutely.
Yeah, because actually it would, if it's killing the host and it kills itself, then that wouldn't be selected for by natural selection. Let's see here. So I'll just go ahead and skip ahead to close. What I've put forward is a method of reasoning. What I've been using in the argument that I presented is abductive reasoning. So reasoning to the best explanation. And this is a standard method of reasoning in the historical sciences. Because when it comes to historical sciences, scientifically explaining things in the past, we weren't there to see it. And so what we have to do is think of what best explains what has been left behind from events in the past. And so this is a method of reasoning that's very standard in historical sciences. It's used by geologists, paleontologists, evolutionary biologists, forensic scientists, doctors when they're trying to explain past causes, archaeologists, detectives, and on and on. And so what they have to do is weigh all the known causes of something. So I thought I had this 6 minutes plus my time. Is that okay?
Yes, it's
Is
fine
it
with me.
okay?
Yeah,
Okay,
it's fine
sorry.
with me.
So maybe that wasn't what you intended.
No, it's fine with
I
me.
okay.
Yeah, I'm
That's-
done, so.
But I should be able to wrap it up in about a minute. So when we're trying to explain complex specified information, we need to weigh all the known causes of complex specified information. This is called the vera causa principle. This is a principle used by Charles Darwin, twice in The Origin of Species. It was used by Sir Francis Bacon. It was used by Sir Isaac Newton, and it's been used by many scientists since then. Well, the only known cause, so we need to weigh all the known causes for complex specified information to see which one's the best explanation. Well, there's only one known cause for complex specified information, and that's mind. That's the only known cause for complex specified information. And until naturalists, until Richard is able to point to another known cause for complex specified information, mind is the only reasonable answer. Now, I have some good news. Richard, if you are able to point to a known cause for complex specified information, you do win a prize. Okay. Not from me. It's a $10 million prize, actually.
I've heard about that.
Yeah, so Dr. Michael Ruse, Dr. Dennis Noble, who you mentioned earlier, Dr. George Church, and the entrepreneur Perry Marshall have developed what they call the Evolution 2.0 prize. And on the website that describes what you need to do to win the prize, they say, quote, "Origin of life is the hardest question in science. No one knows how the first cell came about. But there's a simpler, more fundamental question. Where did the information come from? A new $10 million prize seeks a definitive answer." Well, it's a new $10 million prize, new in the sense that it was new in 2017. So they've been waiting since 2017 for anyone to come along to provide an answer other than mind. By the way, on the website, they specify you cannot use mind as an explanation. And they have yet to find an answer. Now, we can continue to search. I do think continuing to find look for an answer, I think, is perfectly valid. Some of the most amazing theoretical chemistry work has been done by origin of life researchers. So I think trying to look for a natural origin of life explanation has a lot of scientific merit. And I think that especially pursuing some of these new fields like some of these bioelectric signals within the cell, I think is a very interesting field that we need to study more and more. So I don't discourage scientists at all from trying to come up with other explanations. But in the meantime, when we look at something with as much complex specified information as a spec book, 106 pages of complex specified information, I think it's much more reasonable to explain this through an intelligent designer rather than through a natural explanation. So that's my argument. But did you want to, I think you have the last word, if there's anything you wanted to say. You'd mentioned you wanted to say something about Paul Davies, the Paul Davies quote?
Yeah, put that up and let me see if I
Sure.
can remember there was something he said that tipped me off. Did he talk about software and hardware? Or
Yeah, at the very end there.
Oh yeah, that's why I wanted you to bring it up.
Okay.
This guy Michael Levin is saying the DNA is the hardware because it creates the proteins. The DNA says what kind of proteins to do, but the cells do the software. So, and he says that it's even true in human embryos. The DNA doesn't say to do 2 arms and 2 legs. The cells say to do that.
Okay, wow.
So now where does the cells do that? And we don't know. And like you guys probably already know with embryos, if you have all those cells that are about to be an embryo, like once you get enough cells to almost be an embryo, then there's like this, something like a zap, and now it's an embryo. If you were to slice that in half before it becomes an embryo, then each of those cells, separate from the DNA, say, okay, wait, we're not going to be an embryo yet. And each of them they wait and keep replicating until they have enough to be an embryo. That's how you get twins. And that happens naturally. Sometimes it's just an accident, but that's one way to get twins. And scientists can do that too. The cells know they can't be, even though they're going to be an embryo 3 minutes later, you've split it in half. Now they're like, oh man, we can't be an embryo now. And each of them becomes identical twins. It hasn't changed the DNA. It's just, so that's coming from the cells. That's the software. So Michael Levin is the guy who's saying, there it is, but he still doesn't know who wrote the software. But that's a good way to talk about the difference between DNA and cells talking to each other.
That's really interesting. Okay, yeah. Was there anything else you wanted to close with?
Yeah, I was just going to say, you might hear about atheists saying, okay, you do have answers in Genesis, arguing with Discovery Institute, and even they're both arguing with another organization called BioLogos. So like they're attacking each other as if they're different religions. They're all Christians. They're all Christian scientists. But you have that with atheists too. You've got people who tell Dennis Noble that he's, a secret Christian, trying to sneak in teleology, so that people can talk about God. You've got people saying Richard Dawkins just wants to keep sinning. They're probably two guys in their 80s who just see things differently. So atheists are just as fractured and team up. It's a human nature thing. So Christianity doesn't cause people to fracture up. That's human nature. If anything, you guys have stuff about how to handle that, like James saying, hey, we have a tendency to do this, but let's fight that by being more respectful. So if an atheist accuses you of that, say, first of all, you guys do it too, and secondly, we have a set of things to handle that problem.
Okay, very good. Well, let's thank Richard for being here. I do want to open it up to Q&A. Now, I do want to mention ahead of time, you guys are used to asking me questions, and many of you are Christians, and I'm a fellow Christian. We have a unique opportunity here with my atheist friend Richard here. I want you guys to be treat him with the utmost respect. So when you're asking your questions, I think this is a great opportunity to ask questions like an ambassador would ask a question. So Paul calls us to be ambassadors to those who are non-believers. And so how would an ambassador ask a question versus like a lawyer on a TV drama that's trying to get the key witness to crack on the stand, right? I don't think that even happens in real courtrooms, but on TV, right? They're always like, where were you the night of, and they're trying to get them to like sweat and just, oh, it was me. Let's not ask questions like that. That's not respectful. That's not kind. And so an ambassador instead approaches someone with love and respect and asks a question more in the sense of, hey, help me understand your point of view, and I want to help you see, I'm asking you this question because I'm having a hard time understanding how you could come to the conclusion that you do. Help me understand your reasoning here, and I'd like to maybe, through the question, maybe help you see a little bit of my reasoning, but this is not an opportunity for a lecture. Please do put it in the form of a question. But yeah, you can address your question to either Richard or to me. Please don't ignore me because I'm the Christian. But I'll feel left out and I'll go and cry in a corner. Or you can address it to both of us and we could both answer. So yeah, what questions? Yeah, go ahead.
Thank you, Richard, for being here.
Sure, thank you.
So I have two in one. I'll do the White House thing.
Okay.
So the first is, how do you reconcile objective morality in a universe that operates solely on natural law? And the second kind of goes into that. So the second has to do with the Big Bang Theory and creation, right? And so in my opinion, it doesn't matter as much how much we understand about current natural law. I have the privilege of having worked with pathologists and was able to see under a microscope that was 73,000x.
Whoa.
And you could see a whole war going on.
Right.
So they were trying to identify cancer and metastases and all that stuff.
Wow.
And they don't understand, right? The Big Bang Theory to me seems to be void without a creator of the process of the Big Bang. So you can't take a big rock and crush it into smaller rocks and then a billion years later have life coming out of it. So just help me understand those two things. The reason I married those together is they may go together in your response. So thank you for considering those.
I'm going to start with the beginning of everything first. This is a really easy, small question that he asked me, which is, why do we have the whole universe, the entire universe, and why does morality exist? Real quick. Yeah, easy question.
Yeah.
I'm going to start with the origin of the universe first because a lot of people say we just don't know. And the reason why they say they don't know is that when they're talking about space-time expanding, they just kind of backtrack the space-time until it gets smaller and smaller and smaller. And then it gets to the point where there's this really tiny point that's it's expanding, and you can say, like, within a picosecond, you can already start talking about what it looks like or how big it is and the quantum stuff that's in there. In fact, the physical laws of the universe, there's 4 physical forces that we know of, even they're not quite there yet, and there's not even stuff yet. They can get there, and then when they go back another picosecond, then they're like, well, now we don't know what to do. And the reason why they don't know what to do is that whenever you talk about logic, vocab, you're going to love this. Vocab Malone's in the audience. When you talk about logic, you need chronology and you need stuff to talk about logic because this leads to that. There's this at this point in time, and there's this. Now you don't have space, you don't have time, you don't have chronology, so how do you talk about logic? That's not to say that logic doesn't exist, it's just that we don't know how to talk about it within that space. So a lot of people are like, I don't know. But this is why a lot of atheists don't sign off on the argument that something had to create that, because you're talking about cause and effect. And cause and effect certainly works after that picosecond, but did it work before? And then you can say, well, even if it didn't, how do you get that? And so we don't know. So a lot of people say we don't know, and I think that's the right answer, because we can't even measure what we do have before that picosecond. So I don't know why there's stuff, but I am amazed by it. Just the fact that you get that small thing, and it expands, and those quantum things become atoms, and those atoms become planets, and all those physical forces start to happen. Absolutely amazing, blows my mind. And if someone says nobody's behind it, I'm like, okay, but I just can't. I can't sign off on that. I know there's atheists that's like, it's all an accident, it's all whoops, 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 whoops. And I might be doing the same thing I just did to Stephen Meyer earlier. I might be making it sound more mean than it is. But I don't sign off on that. I don't know why you would say that. I don't know why you would say it's unreasonable to think that there's something that wanted it to be there and it's there. I don't think that's how it is. I have a hard time coming up with a creator that understands everything and how to plan. I have a hard time making sense of that. But I understand why people think that, because it is absolutely inspiring that we have all that stuff. I do have an answer for morality, and before I do, does anybody know Eric Hernandez? Anybody? I know Vocab knows him. Eric Hernandez is sort of like Frank Turek. He's like an apologist. He and I are going to debate in Dallas, Fort Worth next weekend on Sunday. So anybody who's going to be in Dallas, Fort Worth area, we're actually going to go to a place called Tulips, which is a sports bar, and Eric's going to go into a place that's going to be mostly atheist to argue over morality. What is objective morality? And by the way, if you guys have been, everybody's been in this class, in here before.
Most, yeah.
So basically, objective morality is like not just what you think is right and wrong, but what is, like an actual right and wrong pressing down on you, saying this is what's right and wrong. How did it get to be that way? I mentioned before that I think morality, and I've actually told Vocab this. Funny thing is that David Wood was in the back of the car when I told you this, and I'll tell you who David Wood is in a minute. But I think that free will is, you've got these organisms choosing between left and right, or these organisms that could do left and right. They're solving problems. So even before you get to humans, you've got organisms that have to choose, do I go towards the light? Do I go away from the light? Towards the food? Do I go away from the danger? And you've got all this noise pressing in on the organisms. At some point, organisms have to navigate through that. Is it through chemicals? Probably. Are they assessing it? At some point, they have to. How does it happen? I don't know. But all these organisms are doing this problem solving, which I call free will. What I think of as morality is an extra dose. It's an extra dose of certainty, so that when something happens that triggers your, and I don't mean trigger in a bad way, it really is a thing that happens. Even if you're the most atheist of atheists, there are some things that you can't stand. You're like, no, I'm going to put my foot down on this. I'm going to stand up and do something about it. That's your morality. That's, in your mind, that's absolute, and everybody else ought to respect that. And notice I said oughta when I said that. Is it a real thing, or is it an illusion? I think it might be an illusion, but it gets you moving. So I've always said that morality is that extra dose that says, I'm definitely going to do this. And one example, what I'd be like if you and I are like driving down the street and we saw like a bus on fire, we would stop the car and jump out and go and try and save the people in the bus. It would just stop whatever we were doing, because we thought we can't have that bus, keep burning. We got to pull the school kids out or whatever. That sensation that gets you to move, I think biology just said there's going to be certain times when you're going to stop thinking, you're just going to do it. And natural selection, I understand natural selection is not actually a thing. Natural selection is just whether you're here or not. But if you talk about natural selection as a thing, it doesn't care why you do something. It just cares what you do. So basically natural selection would say these are the kind of people who help kids in a school bus. Because of that, the kids grow up and do better. So these societies do better. And that's why. Is it because God told them to? Maybe, but whatever. For some reason, they all stop what they're doing and they go save the school kids. And that's one reason why they're still here. So I do think it's natural. I don't know why it's natural. But I do want to point out something that atheists often don't say, which is that we don't see this as the same as preferences and opinions. So, like if I have a favorite ice cream and vocab has a favorite ice cream, I'm cool with that. But if I'm like, let's go save the school kids, and vocab's like, let's go have ice cream instead, I'll be like, what's wrong with you? He's triggered something. So there's something different between this and preferences and morality. Is it still part of our epistemology, just more stronger? I think so. But at the same time, I'm not going to act in compliance with that. I'm going to act like it really is something real, even if it probably isn't.
Okay.
It's a long answer, but it's a good question too.
Other questions? Yeah, go ahead.
I have like a million questions.
Maybe start with one and we'll go.
You covered far more ground than you did on the topic at hand because you went through vibrations and quarks and all that stuff, which I actually just heard.
I was going to say, we've known about this for a year, so I've had a year to think about this.
Well, you said a lot. I mean, but I keep hearing why all the time, and I'm kind of like, you're really an atheist? Because, oh, God, maybe.
I get that too, to myself. I'm like,
Probably
you
that
sure?
energy from your earlier life just
Yeah.
spinning around. So I'll distill it to, so you started talking about the energy, the quantum waves, which is vibration,
Right.
right? And then
Well, yeah.
I just recently heard somebody talk about that, God slowing vibrations down so we can see it. 'Cause you can vibrate things, everything in this room to where you can't see it. So if it slows down, then you can see it.
Okay.
Is
Right.
that true?
I don't know if
It's
that's
kind of in that realm,
Okay.
but then, so then you went into the cells having the energy and talking to each other,
right.
and then the cell does something,
Right.
but you can't have it, so you can't have that without having the energy is DNA comes first, energy comes second, or else the cell's never gonna do anything, right?
I always think of life like this. I think that everything is a chemical reaction. So I even think chemical reactions and something like the Krebs cycle happened first before life. So maybe there was something processed very similar to life, but not quite life before you got to life. So I think all that requires chemical and energy to have this process. So I say there was processes first, and then there was life. And so when you got to life, now you're replicating. Now you have very specific goals. So I think life is a more complicated version of these processes that were happening before. But I think it's all chemicals. Chemicals and energy. You need the energy to have the reactions.
True, but then you come back to James's first cell membrane
Right.
harvesting products
Yeah.
to even exist in the first place. And
Right.
then this, I'm sure you know about the guy, it says time is a factor, it's not billions of years, because you have to preserve that material in a
Right.
24, 12, 4 hours, whatever it is, or it's gonna die, so you don't have a chance. So, but we're talking about the intelligent signals. The intelligent signals are signaling something that exists, which is the DNA. So that's piggybacking on top of the actual cell with the DNA, because without that, you can have the DNA without that, but you know what I'm saying? It's you can't have that energy and that thought talk in the cell without having a cell.
Right. I think in order to get where we were, there had to be stuff that was close to this, but not quite this. And then later it became like that. But I don't know how that happened.
Well, and so then here comes up, I heard why 1, 2, 3 times, and it's like, to me, it's like, what purpose has an orange, or why does the eye have a purpose to see?
Right.
And there's a bunch of whys. I don't think in 10 years we're gonna get to an answer about nature, but.
Right. I don't either. I was just saying if it does happen, at least nobody has to worry. I think maybe some of these institutes will worry because they didn't think it was going to happen. But there'll be another institute. The next day, there'll be another institute that says, this is the best fine-tuning argument I've ever seen in my life. And it will be. So for me, I'm just saying if you're part of that institute and you think that it's never going to happen, don't worry if it does. It's actually, there's nothing wrong with nature answering everything, especially if God exists. If nature answers everything and God doesn't exist, then atheists should be like, what the heck? But you guys should be like, of course it does, because God made nature. So you guys have no reason to worry. I think a lot of Christians have pitched this idea that you should worry about it, and I'm saying the opposite is true. You got nothing to worry about.
I don't, so.
Okay,
my reading-
after this,
I
then
really
we
don't
should
think
give
it's-
someone else a chance, but yeah, go ahead.
The question, this energy that talks about adenine here,
Mhm.
adenine there, do you think that leads to adding more DNA and stepping up?
Yeah.
From that critter to
Right.
this critter to that critter?
Now, I can't prove this, but this is what I think. I do think this is going to answer that question, because you have all these scientists who for decades, since the 70s, have said the advancement of a species was only mutation from here to here. But I think it was the cells adding things, maybe by accident, maybe not a mutation, but like the cells saying, okay, we're gonna do this, and that added features, not the DNA mutations, but the cells just saying, we're going to do this. Why do they do it? I don't know. You know, this might be where Bill Dembski said, well, this is what happened. The real-time signal came, and then the cells did it, and then you had a new species. But I do think it's something like that outside of the DNA. It's still a mystery, and and you're like, okay, well, show me who did it, and I don't know. So none of this, what I'm telling you now, doesn't help atheism, but I'm hoping it tones down this concern that a lot of Christians have, like, oh my gosh, if it's not DNA, and if it's not God, then what? It won't matter. You can still say that God made things that way.
Oh yeah, go ahead, Matt.
So, piggyback off of what you just said.
Yeah.
So, when you were just talking about the amphibian, and there were previous versions where you could cut off the leg,
Yeah.
and it had
It would-
knowledge to regrow it.
Right.
Same thing with like the cavefish, where it's like they don't have eyes, but as soon as you put them in sunlight, it
Yep.
triggers and kicks on.
Yeah.
So, but you're saying that from that, well, those were already DNA things that already existed, and
Right.
they're just getting turned back on.
Right.
So, where are there examples of things going beyond what's already there?
Right. Yeah. I don't know. That's a good question. And I wasn't. And when I was doing that expression, I was just I was fighting the atheist narrative that it has to be genes. When I was doing that, I wasn't really trying to defend naturalism so much as just to say that is definitely wrong. The idea of genes and just mutations, we can now disprove that. I think there's enough research now to say there's something else going on. Certainly amazing genes, but now also amazing cells for some reason that have goals.
Great. Yeah, vocab.
So the problem of life's origin, I think the big problem there is how to get the first cell.
Right. Absolutely.
Most scientists, I think, have abandoned the idea that it's spontaneous generation.
Right.
But whatever it would be, seems that it would look exactly like what a miracle would look like. So here's a quote from Michael Denton, a molecular biologist. Tell me what you think of this. I want to get both of your guys' reaction if I could, because I'd like to hear you too, James.
Okay. Yeah.
Quote, the complexity of the simplest known type of cell is so great that it is impossible to accept that such an object could have been thrown together suddenly by some kind of freakish, vastly improbable event. Such an occurrence would be indistinguishable from a miracle.
You want to go first?
Sure, yeah, I could go first. So yeah, I think what Dr. Denton's getting at there, he said Michael Denton, right?
Yes.
Yeah, so I think what he's getting at is when we look at even the most simple single cell on Earth today, he said it's more complex than any machine ever built by man. The sort of networks that you see within it, and I think, Richard, what you were talking about gets into a lot of this, that there's far more code in there than just the digital instructions built into the DNA, that actually the cytoskeletal structure and all these other things, there are actually multiple codes in cells, and we're discovering more, like you said, these bioelectrical signals. But when he says thrown together, it might seem like, well, that's not what the naturalists think. They don't think that just chemicals just like suddenly, like you just dump all the chemicals together. There are different theories about how you might be able to form an early form of metabolism, something like the Krebs cycle. Nick Lane talks a lot about, Dr. Lane talks a lot about a metabolism first model or whatever. You're still going to need all three, some form of all three of those to get a replicating system actually going. But here's kind of what I think Dr. Denton was getting at is that, for example, RNA, which you're going to need something like that, can only survive for about 19 days. Maybe there are ways that maybe at a reasonable temperature, a plausible temperature, maybe you could get it to survive for as much as 12 years. But you're going to need it to stay there for millions of years in order to build up enough RNA to actually have a saturated solution enough that you can actually get combinations of RNA to actually get them to ever form a code, something like that. And that still doesn't explain where the information came from, but just to form like a long sequence together. Also, some of the bases, remember we called those rungs the nucleic acids. Those are the nucleotide bases. Two of those, adenine and guanine, require freezing temperatures to form, while cytosine and uracil, which are different ones, require boiling temperatures to form. So you need vastly different environments for these things to form naturally. Well, how are you going to get an environment that has freezing temperatures and boiling temperatures in the same location for all these chemicals to come together to form RNA? So I think there are all sorts of problems like that. By the way, any of these, when he says throwing chemicals together, these sorts of natural chemical processes, anytime we've tried to model these in the lab using naturalistic conditions, conditions that you would expect on the early Earth, even somewhat plausibly, you get very small yields of the chemicals that you want, these very delicate biochemical structures that you need, but yet you get large yields of stronger reactants, other chemicals that react much more quickly and strongly with those more delicate components. So you're actually going to have like a very delicate, important biochemical structure in a soup of other chemicals that react much more readily with that, and it'll just tear apart those more delicate biochemical structures. So I think, at least up until now, and I'm totally open to new evidence coming along, but up until now, I don't think we see that chemicals coming together, even in these sorts of theories, they're not going to come together to form these sorts of structures that we see, even some of the basic components. But anyway.
Yeah, and I was going to even use that word miracle too, because I wanted to check my YouTube, because on the way over here I was listening to Nick Lane as my final cheerleader as I was coming in here. So there's a channel on YouTube called Theories of Everything, and it has with the host of somebody, and Nick Lane is on there. If you just listen to that for 10 minutes, he'll talk about what you were just talking about, vocab, and he was like, you have to have all these things that happen. You might as well say a miracle, because he's like, we're not going to know all the things that had to happen. He does think that some sort of a process happened first, and that somehow over time these processes became something like a cell. But another thing that atheists got wrong was that they thought going from non-life to the cell, they just put that off. They were like, okay, we'll get to the non-life to the cell. The big problem is getting from the cell to the dinosaur, because that's going to take forever. But it turns out that's not even close to right. Getting from the cell to the dinosaur is incredibly difficult, and they don't know how to get from the cell to the dinosaur. But that's nothing compared to getting from the molecules to the cell. They're like, there's your problem. There's your billions of years or more and all the different things like that. And that's why he said, I don't know. Imagine how complicated it is from the cell to the dinosaur. That's nothing compared to molecules to the cell. So miracle is probably a good word for us. I would only say, if I'm going to be the bad guy in this room, and I guess that's my job to be the bad guy. I mean, I would say that throughout history there were times where, say, a lightning strike happened, and they were talking about where to go, and then a lightning strike happened, and they were like, hey, guys, we just got a message. And they didn't. It was just a lightning strike. And maybe someone spoke up and said, hey, maybe there's a natural explanation for language. They probably didn't talk to that guy anymore after he said that. That was probably not welcome language. They would have said, no, we were talking about something, lightning struck a tree, there was a fire, miracle, and it turned out it wasn't, but at the time they absolutely believed it. They would have used the word miracle. I'm open to the possibility that things that seem unfathomable to us could end up being explained by nature. That doesn't mean that what we're doing now is as ignorant as what they were doing 20,000 years ago. I'm just saying I'm open to the fact that we don't understand things enough in the same way they didn't understand things.
All right, we have time maybe for one more question, and then, yeah, go ahead.
I just want to say I really appreciate your perspective. It's kind of refreshing without all that yelling you guys are talking about.
Right.
Yeah.
So I'm curious from your perspective, why do you take the atheistic standpoint?
I guess I would have to have like a reverse testimony. I would say that I was, so I'm 54, I was raised in a kind of Christianity that's sort of alien to a lot of the way people are raised now. The church was great, but even on TV, if you woke up in the morning and turned on TV on Sunday morning, the pastors would say that the scientists are trying to trick you and Satan's trying to trick you and stay away from science. And all you got to do is believe the word. A lot of prosperity gospel. It came across like a scam. I'm not saying that people at the pulpit were scam artists, but I honestly think if you have enough followers, you start to think that whatever you think is true, and then your followers are going to go with that, and you end up having things like what happened in the 70s. So I think I had a lot of reason to say Christianity is probably not right. I didn't get into the apologetics, intellectual Christianity until the late 90s, early 2000s. So maybe if I had been raised in that, then I wouldn't be like this. But I was certainly raised in the kind of Christianity that's easy to walk away from. And they say even now Christianity is still is growing, and certainly atheism. By the way, all the atheists are like, there's nothing, leave it all alone. Those guys are converting from that too. So I think you have like the angry atheists that say religion is brainwash. I think a lot of them are converting to there's something. So I believe in some sort of higher power. But also a lot of evangelicals are saying, this is all true, this is all true. A lot of them are saying, okay, maybe this is not true, and maybe this part is not true, but there is something. So I think they're both kind of converging onto this, I believe in a higher power. And I'm probably a lot more open to that than to say more like evangelical Christianity. So it would be something like how I was raised, but also I think that there are so many Christians and there's so many different versions of it that I would not know. Even if I did want to be a Christian, I wouldn't know which one. I would probably just go based on how I was being treated and how they treated my family if I did do something like that.
Okay. Well, thank you everyone for coming. Thank you for the great questions. Please, again, let's thank Richard for coming.